Hi, this is Victor Morganti from FactEngine. Today we'll be looking at natural language queries over a database, or more specifically, semantic search that is schema aware over a database. Now we're looking at the schema for a database inside the Boston conceptual modeling software, and it's the Northwind database supplied by Microsoft. We're looking at the property graph schema view of that database, and where it becomes a property graph schema view if we control left click on a node type and we can see its properties. So employee has these properties, customer has these properties, supplier has these properties, etc. The Northwind database is for storing information about orders that were taken by employees, where the order is for products that were ordered by a customer, and where a customer is in a demographic, and where an order is shipped by a shipper, and where a product has a supplier, and where a employee services a territory that's in a region. This particular edge here, employee covers region, is a derived edge type in Boston and FactEngine, where we're saying that if an employee services a territory that's in a region, then an employee by default covers that region. Now, we know in Boston and FactEngine that we can morph between, say, the property graph schema view of a database and its corresponding entity relationship diagram. So this is the same schema but visualized as a entity relationship diagram, and where Boston and FactEngine treat every database as if it were a multi-model database that can be visualized as an entity relationship diagram or as a property graph schema. So that's the property graph schema view. We can say click on customer and we can morph to the entity relationship diagram view. We can also visualize in Boston and FactEngine our model as a set of object role models, and where this particular object role model covers the relationships that define the employee table in the entity relationship view, or the employee node type in the property graph schema view. For instance, we can say an employee has a country, and if we click on employee has country, that fact type, we can also see that it has readings country has employee, but also where employee is based in country. So when we look at our entity relationship diagram, we can click on the country column and see the predicates that relate to it. So employee is based in country, or employee has country, or country has employee. Now this becomes important when we want to traverse the schema in a natural language query, or with semantic search that's schema aware. So for instance, when we look at, say, product and supplier, there is a relationship between product and supplier, where a supplier has many products, and if you know the product, you know its supplier, and there's a predicate, product is supplied by supplier. But also, if I go to the supplier's city column, I can see where a supplier is based in a city. So not only can I click on city for employee and see that employee is based in a city, but I can see that a supplier is based in a city. So I can traverse this schema by saying, show me the orders that are for products that are supplied by suppliers in a particular city. Or we can make it interesting by saying, show me the orders for employees that are based in London that are for products that are supplied by suppliers based in the same city. So let's go to FactEngine and run that natural language query. Now, FactEngine is available as a web-based API or a set of DLLs if you need that. We're running FactEngine inside the Boston conceptual modeling software. So I'm going to say, show me the orders taken by employees based in London that are for products that are supplied by suppliers based in that same city. So that'd be quite remarkable if we could turn that into an SQL, for instance. So let's give that a go. So we're going to hit go on that. And what FactEngine has done is it's converted that natural language query to a controlled natural language query, which reads which order was taken by an employee that is based in the City of London and is for a product that is supplied by that should be but that's okay, a supplier that is based in the City of London. We said the same city, but it's cleverly duplicated the City of London there. So we've got a successful result, and these are the orders. These are the name, first name and last name of the people who took the orders, the product name and the company name of the supplier that's in London for the products for that order. And here's the SQL query behind that. So we could change London to say Singapore, and we'll change that same city to Singapore. And we've got our result. So if we're looking at our entity relationship diagram, we said show me the employees that are based in London, or show me the orders for the employees that are taken by employees based in London that are for products that are supplied by suppliers based in Singapore. Now, what would be remarkable is if we say based in the UK, which is not a city at all. So show me the orders taken by employees that are based in the UK that are for products that are supplied by suppliers based in Singapore. Now what we want that to resolve to is where we're looking at orders that are taken by an employee that is based in the country UK and is for products that are supplied by suppliers based in Singapore. And so FactEngine has correctly done that, and it's done that by using the resolution from natural language to controlled natural language via a large language model. And where the large language model is intuitive enough to recognise that the UK is a country rather than a city, and convert our controlled natural language accordingly, where we're looking at the country UK rather than the city of UK when we said it otherwise based in London, where it would have said City London. So that's a good result so far. If we look at the schema again, and let's say we want to have a look at the sum total of the unit price for orders taken by a particular employee. So I know there's an employee called Nancy in there, and I can say, for instance, show me all the employees, and we'll get a list of employees come back. And the first employee that's come back is Nancy DeVolio. Now I want to know a very specific thing about order details for orders taken by Nancy. So I'm going to say, show me the sum of the unit price for order details of orders taken by Nancy in December 2017. Okay, let's give that a go. Right, so we've got a result, and what FactEngine has done is converted that query into a controlled natural language query to get our results. So the sum total of the unit price for the order details for orders taken by Nancy in December 2017 is $461.25. And we know our query is going to be right because we can look at the controlled natural language query and verify that it's correct. So employee Nancy took an order that was placed on order date and the month of that date being the 12th, and placed on the year of the order date being 2017, and that has an order detail that has which unit or unit price, and we're returning order detail unit price sum, so the sum of the unit price. So $461 is the sum total of the unit price of order details for orders taken by Nancy. Now we've just said Nancy, we could say Nancy DeVolio because the query at this stage is looking up anybody called Nancy, and there might be multiple Nancys. So let's narrow it down to Nancy DeVolio, and we'll see how that changes. And now we've got the same query, but we've got employee Nancy DeVolio. So Nancy DeVolio took an order that was placed on the 12th month and placed in the year 2017, and has an order detail that has which unit price, and we're returning the order detail unit price and the sum of that unit price. So that's a brief introduction to semantic search that is schema aware in FactEngine, and where our natural language queries are converted to controlled natural language queries that are converted to SQL or Cypher or TypeQL for TypeDB to get our results. The semantic search is schema aware because behind our natural language query is a schema that can be visualized as an entity relationship diagram or a property graph schema or a object role model, and where the secret sauce is that the object role model gives us the level of granularity that we need to identify the predicates in our controlled natural language query to be able to convert that to a successful database query in SQL, Cypher or TypeQL. Thank you very much for watching. I hope you enjoyed the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.